Hi again. Well, last time we have left where we were talking on the models. And for the models, we can say that models are representation of the real world. And usually, I mean, of course, not all sides of the real world, but a certain aspect of the real world. For example, we might have a linear model with graphs of demand and supply, which might be representation of a market. Um, Market for example, cars or market for labor, uh, or we might have a bunch of formulas which might be representation of, let's say, a physical world, how a specific action or specific force in physical world, like kinetic energy and um, the formulas, for example, of kinetic energy shows, well, basically it represents the different factors that are affecting kinetic energy in a body. Models can be also sometimes, usually we don't have it in economics, but sometimes also done in shapes or in miniature size models might exist, which might represent larger bodies, for example, and those models can also be tested, by the way. But whatever model we are talking about, models are imperfect representation of the reality. For example, in a typical model with demand and supply, we don't take into account the actual process buyers and sellers need to spend to find each other, basically. We also, for example, have, well, intermediate agencies that are regulating the market inside of the model. We might try to bring them into the model, but the model itself has a limits when we bring them in. They are not represented by the lines, or their function is not there completely inside of the model. I mean, their main objective and the way their policies are benefiting greater economy is not represented in the model. Rather, only their effect on the market is represented in the model. So those imperfections should be in our mind, especially if we are aiming to understand how real world is behaving. Just creating a model of the real world and seeing a certain behavior of the behavior or certain characteristic in our model doesn't mean necessarily that characteristics also apply to the real world, basically. Well, for example, in a model, we might say that the typical sellers and typical buyers tend to find always their counterparts who are giving them the best offer. For example, typically we might say that demand, and in the case of demand and supply, the price level at which people are selling and buying their products is become the same. You will have a certain market price. In reality, that might not be the case. Different buyers and sellers meeting at different environments might be selling and buying certain the products at different prices, and this might be not that important if the price differences are not too high. But this might also be important, and in some cases we might not necessarily know before we basically test it, whether these type of small differences are really important or not so important. But we should at least know these imperfections of our models. After we know those imperfections of the models, we might basically use our model, well, in two ways. We might already have a proven theory, which is proven in the real world with facts, with empirical evidence. And we might use the model to tell the narrative of this theory. For example, for high schools, people who are not understand, I mean, even in the university, if you are not an engineer, you might not that much understand how the electricity really works, because it's the movement of electrons is really complex thing. So in order to simplify it, sometimes electric circuits are represented by a model of water flow. It is told as if instead of electricity, water is flowing through the cables and lines, basically. And the logic of water flow is water flowing through the cables, I mean through the electric circuit. Logic of how water flows is used sometimes to tell the very basic principles of the electric circuits in some cases. So models can be useful in telling narratives. Models can also be useful in creating a framework. I mean, we might create a framework with imperfections, and we might look to the framework, and we might think, well, in real world, maybe this type of an effect might be existing, we might say. So by creating a more, basically we create the model because it is more simple, it is easier to observe, and this simpler version of the real world, which is easier to observe, may make us to find certain connections, make us to suspect or think about possible connections, possible characteristics of the real world. And we might use the model to think about these potential connections or potential characteristics. But once we get them, we need to test them in the real world, basically. Another thing we should be careful of is basically assumptions and simplifications. Basically, simplifications and assumptions might be similar in some sense, although assumptions might sometimes overrule the simplifications. A typical simplification is usually, making the model in a taking a model and creating a simpler version of it. Like, for example, you might have 10 buyers, millions of buyers and sellers interacting with each other. You might just assume 10 of them interacting with each other, or in a very extreme case, one buyer and one seller might be interacting with each other. Basically, that could be a simplification, and you have a more complex world, but you create a simpler version of that complex world by keeping the central characteristic there, but kind of reducing maybe number of agents, reducing maybe certain not so critical differences between the agents. So you create a simpler model, and you basically discard certain information which might be not important for you to test what you want to test or show what you want to show. For example, if we just want to understand the best route of an airplane from Istanbul to Paris, for example, the shape of airplane is not important, so you might just take the airplane as a point there. So the typical assumptions are however, usually something different. For example, take the airplane example. We usually don't say that I assume airplane is a point, although in case of simplification, to some extent we have done that. But usually, in order to make prediction, you might say, I assume the wind will flow, wind will go in this direction, for example, or wind speed will be less than this amount. for example. Kind of, this is also a simplification, but you are also putting certain conditions in which your model is working. Well, when I say, for example, in economics, I assume more is always better, which basically means that people always get more utility, more happiness when they consume more of any commodity, any products they consume. I make a definite assumption on the real world. I mean, this is not just pure simplification. I mean, I didn't take a complex elements and reduce the elements to the simpler, to a simpler form. Rather, I have made an assumption on a characteristic of people acting in the real world. That assumption might be realistic or useful if either the exceptions to this assumption are very small in numbers and negligible, or alternatively, maybe their effect is not important. Well, more might be not. More might be at some point maybe more might not give more utility, but that point might be at somewhere too high. I mean that the reality that more is better is wrong at some point might not be that much important in that case. But as both in case of assumptions and simplifications, we should be very careful because they are setting certain limits to our models, especially assumptions. Very famously, for example, in engineering, during the Second World War, in the United States, these huge ships were designed by welding, and welding technology, in theory, was working very well. But when the ships go through the Atlantic Ocean to the England, actually, when the waves hit them at the northern parts of the Atlantic Ocean, well, the metal cracked. Why? Because, well, basically they didn't take into account the temperature. So assumptions pretty much put implicit or explicit assumptions pretty much put limits on our theories or models. I mean, if whether or not our models work in a world, whether in the world those assumptions are violated, and whether or not our models work in the world where those assumptions are violated should be basically tested. For math, let's talk on math a little bit. Math can be a useful way to basically describe and basically put in place a model. Even though it is thought as something complex, in some cases with mathematical formulas create more clearer models than the ones that will be expressed in words. Because I mean, you can see relations more clearly in mathematical forms. You can test those relations or bring those relations together easier in mathematical forms than in the word forms. It helps you to visualize the model or the effect in your mind. I mean, this demand and supply curve, for example, on graph, helps people to visualize the effect of demand and supply, basically. But math is only useful if it makes it a model more clear. Math is useless if it obscures, if it makes it more difficult, especially if we put more complex math and if it makes the theory more difficult, then it is not useful anymore. So the rule of thumb is basically you should make the model as simple as possible, but you should also make it complex enough to put all the necessary elements into it. Anyway, let's finish here. And let's continue the next part.